So good morning all and welcome back. Previously, we were working with applications of stack, right? Now this is lab session, right? And previously we were working on a practical. So actually the program of infix to postfix conversion, and we had completed that program where we actually make use of stack that we have already created in practical number 3. So we make use of that stack file and we use that stack to convert infix expression, given infix expression, to the postfix one. And that was our 4th practical. We completed it in last session. Today, we want to go for the next practical, 5th one from your practical list, and it is a simple queue implementation using array. We'll be following the same thing, same structure of files. We'll be having 2 separate files, one for the demo file, another one for the implementation. And we will be testing that entire simple queue here. So as always, let me go for entire explanation here. You just sit quietly and understand everything, whatever I'm explaining. Once I'm done, then you'll have your time to implement this entire program. So starting with today's content, we need to write a program to implement a queue, simple queue using array, and that performs number of operations, the basic operations that we have seen in the lecture session also. So we need to go for those operations here. Now, if you remember the demo file that we have created in stack. Now let me bring that entire demo file here. So this is the entire demo file of stack, right? Demo of stack, and this is what we have created in the practical number 3. Now the structure, because it is a demo, structure of this file is going to be the same. And the changes that we need to make here are related to queue. So instead of stack, we are going to have this demo of queue. So we need to create one extra file here. We call it let's say simple queue, or simply a queue, queue.h file. So this becomes demo of queue now. In this file, I'm going to make necessary changes. So this becomes demo of queue. Now declare a variable of queue here. So that declaration will be something like, instead of this stack being abstract data type, we will create queue as an abstract data type. We'll create it in the header file. And the variable for me is small q here. Now later on, I know that I'll require val variable, ch variable also, position variable also. So these are the simple variable declarations. And then we call functions to perform operations. In our queue, there will be init operation, and we are going to pass our queue variable, right? So initialization of queue. Then instead of push, pop, peep, and so on, in terms of queue, we have insert, delete, pick, change, display, is empty, is full, and exit. So these are going to be going to remain as it is. Just the pre-function names are changed. Instead of push, it is insert. Instead of pop, it is delete. And instead of pip, it is pick. So we change that that menu items here. Now this is a menu, and these are the operations on queue, right? So we have listed all the operations, and then we ask, please enter your choice, and we have one choice. Now based on that choice, we have a switch case. Now case number 1 is to insert. So we ask one value from user, and then we call queueInsert function. Now this is a user-defined function name. You can have it as whatever you want. queueInsert is a function, so that's case 1. Then case 2 will be queueDelete. So second case is for delete operation. Now definitely we need to pass queue variable when we call these functions. So delete function will return one value and we print that, and instead of popped value is, we say deleted value is, and we print that value. Then the third case is queuePick, and we pass our queue variable. So we take the front value from the queue. So topmost value, instead of that we say front value is, and we print that value. So that's pick operation. Then fourth case is for change. So we say queue change and we pass queue variable. No change in this part. You take a position, you take a value, and you call your function. The function name will change. Then we say queue display, and we will pass queue variable. Is empty, queue variable. Is full, queue variable. And when we say yes, queue is empty, and we'll change these feedback messages. Queue is not empty, queue is full, queue is not full, and done. So with minimal changes, actually we are done with the demo file right now. So this is what I can say. This is my demo file for simple queue. Now we need to implement simple queue in a header file, which is not done yet, but this is a demo file. As you can see, demo file structure is going to remain same. We have done minor changes. Instead of stack, we have changed everything which works with queue. So this is my queue demo file. Let us save this project. This is gonna be PC1-C-Batch simple queue. PC1C queue. This is my project name. Simple. And now let us go and create the queue.h file, this one, right? So I'm going to create a new file. I'll call it queue.h, and this is my new header file in the same project. Now, if you remember the structure of our stack header file, then it was something like this one. Let me bring that code. Implementation of stack using array, and then we started defining our user-defined data type here, and then we had gone for operations: init, push, pop, peep, change, and so on. We have number of operations here. So instead of those operations, now we will be having queue operations, and the necessary code algorithms will be implemented here. So I have not brought entire file, but initial structure to make you aware how we had started our stack as an abstract one. So here we'll say implementation of queue using array. I'm going to establish here stdlib.h, and maximum size is, let it be 5 right now. Queue size is 5, and then I'm going to define queue as abstract data type. So type def struct, this is going to be queue. Now in queue we require one array, and then instead of top we require front and rear. So f and r, two other variables, and we give it a name queue as an abstract 1. This is now going to work as a data type. Once we are done with defining a data type, we can go and define operations on Q. And the first operation is init. In init, we are going to pass one variable Q. So we receive it here. So why we have pointer variable, you already know, because when you call a function and you pass your variable, it is called by value, and that creates a copy. We had a problem with that, so we moved to call by reference. When we pass address of Q from this main file here, when we call init function, we pass address of our Q variable. So we require pointer variable at this place. Now in Q init operation, what we need to do is we need to initialize this F and R, front and rear position. So we have a Q variable. Using Q, we access our front and we access our rear. And at the time of initialization, we are going to initialize it with -1. So this is our init operation for Q. So we are done with init also. And now actually we need to have insert operation, delete operation, pick operation, change operation, then display operation. I'm going to define all these operations one by one later on. But let's have a list of operations that we need to define. Is empty and is full. So these are the operations we need to write here. So now what I'll do is I'll go and define one by one operations, functions here. Simultaneously, I'll be explaining those lines. What you can do is you can keep your algorithms side by side, and you can compare those algorithms with these functions, whatever I'm writing here. So you'll have idea how algorithms are converted to programs actually. So let's go and define insert. It's not going to return anything, so void. Then Q insert is the function name we have decided earlier, and it is going to have two parameters. First one will be Q variable, and the second one will be simple integer value to be inserted. Now when you go for Q insert, how do you insert? In a Q, insert operation happens at the rear position, and the value will be inserted in your data array. Data is a member of Q, so you can access it using Q points to data, and then at a rear position, so Q points to R. This is where we can insert a value. Okay, this is the actual place where we can insert a value. But currently R is having value -1. Currently R is equals to -1. So before we use that R as an index, we need to update our R. We need to increase our rear place. So R++, and then at the place of R, we save that value. Now, at the first time when you insert your value, okay, for the first time when you insert your value, your front is also -1. So we need to update that also. So at that time, we also need to update front as 0, and simultaneously for the first time when we are inserting a value, we should make R is pointing to 0 also. And in other cases, we simply increase our R. So we have one if condition here. If your front is -1, and at the same time, if your rear is also -1, then at that time, you make front 0, rear 0, else you simply make r plus plus. And once you are done with this incrementing or updating your front and rear, then you insert your value at a rear place. Now if we have inserted that value, let us have the acknowledgement message. This is just the acknowledgement message. This part is actually the storing value part. And this is how we can store a value, by updating either front or only rear, and then at the rear place we store the value and we give a feedback message. But every time it's not possible that we can do this process and we insert a value. What if our queue is already full? Well, in that case, instead of going for this process, okay, we need to check first, what if our queue is full? If our queue is full, then we should give user a message, queue overflow. And if your queue is not full, then in the else part, you can do this entire process of inserting a value, and then else part is over. So this entire process will be in the else block, because if block has overflow message. And that's how we perform if else here. Now what should be the overflow condition? How can we say that our queue is full? Correct, yes. We need to check our rear place. So Q points to R, and we are going to compare it with our maximum size. Now, as long as this is a program and we are using array which is 0 base index, so we need to write max minus 1 here. So if your rear is already max minus 1, then your queue is full. You cannot insert a value. And if it is not max minus 1, then we go to else part, we increase our rear, and we store the value and value inserted message. So this is the entire insert operation. Insert operation on a simple queue. So now when we insert some values and we want to check whether actually these values are inserted or not, then to check it, what we can do is we can display our entire queue. So let me go and write display first. It is just going to display. So queue display operation. It's going to have one parameter, to pointer. And here, if our queue is already empty, then we give a proper message to user that queue is empty. And if your queue is not empty, then in the else part, we can print our entire queue. Queue contains, and then we actually want to print the data that we have stored in our queue, but data is array, and we want to print our entire array. So what we need to do is we need to go for a for loop where we can print. It's a simple integer value, so %d, then one space to differentiate two numbers, and then q points to data of I. That's what we are gonna print. Now I, so that's the loop control variable, as well as we are going to use that I as an index variable here. So I is going to start from somewhere, and I will range up to somewhere, and then we need to increase or decrease I. Now in terms of stack, we started from top and we go up to 0. So that was a reverse loop. So we make I minus minus at that point of time. Now here in a queue, queue will always be in a forward manner, from front up to rear. So I will start from front, Q points to F. It will range up to, so less than or equals to, rear, Q points to R, and then I plus plus. So this is your for loop to print your entire queue. And once you print your entire queue, you are done, right? So this is my display operation. Now, if I want to check these two functions first, still we are not done with other operations, but let us save this code and let us test it. Now, if I run this code right now, then it will not find these operations, delete, peek, change, and so on. So because of that reason, let me comment this out. The functions that I haven't defined yet, I'm going to comment it. Right now, I'm going to comment those out. Later on, we will uncomment these things and we'll test it. So that just to remove all those errors at present. So let's test. We are done with init, insert, and display operation. Now, if I run this code, oh, we have few mistakes. First one, unknown name Q. Yeah, it should be capital Q because our data type, user-defined data type is capital Q. So I made that mistake here. That's one thing. And another thing, so we need to define this emptiness condition. Q is empty. How can we say our Q is empty? If, first thing, if your front is still at -1, yeah, that's the initialization status. So when you initialize and directly if you go for display, then you can say, oh, your queue is still empty because your front is at -1. Now that's one condition. Or there might be another condition also. You have inserted 3 values and then you have deleted 3 values. So your front and rear will not be -1 or 0. It will be somewhere at 3, 4, and so on. So when you insert 3 values, your first value will be at 0, second will be at 1, and third will be at 2. But when you delete some values, your front will go beyond, it will pass rear place also. So in that case, your front will be greater than your rear position. This is the second condition. If your front is greater than rear, then also you say your queue is empty. So that's the emptiness condition. Let us save. And now let's run this code to test what happens. So first message, queue initialized. So our queue has been initialized. So front and rear both are -1 right now. And we can test insert and display operations. So if I directly go for display, then it says queue is empty. Okay, that's perfect. Now let's go and insert some values. So option number 1, value is 5. Option number 1, value is 6. Option number 1, value is 7. So we have inserted 3 values, and every time we had this message, value inserted. So the front value should be 5, then 6, and the rear value will be 7. Let's display it. So we have queue contains 5, 6, 7. So display operation is also working properly. We have tested it, and let me terminate this execution. So option number 8, we are done. So you should also go like this way. You do or you write one operation and you check it. Initially, you need to have init, insert, and display, 3 operations, and then you will be in a position to test. But now on, as you have a display operation, every operation you can write and test. You write delete and test. You write pick and again test. You write change and again test. Like that way, you can go for testing your entire code. So that's the overall skeleton of a program. Now you have that idea. I'm going to complete this entire program now, and then I'll test my entire program. So we'll be done at this practical. I'm going for emptiness and full first, because we have both those conditions here. For Q to be full, you have this condition, right? Overflow condition. So that can be written here. Now, what is this is full function? It is going to return either 1 or 0. So return type is integer. Is full function, and it will have one parameter, your Q variable. Now, to check whether our Q is full or what, we can have this condition. If Q points to rear is max minus 1, then yes, Q is full. So we say return 1. Else, we say return 0. So that is our full function, is full function. Now, similarly, I can define my empty function also, is empty. And again, is empty will have one Q variable. For emptiness, we have this condition that we have written in display. So let's use that function, condition here. If your front is -1, then your Q is empty. Or maybe your front is greater than rear, then your Q is empty. Otherwise, return 0, Q is not empty. So we are done with these two functions also. Now I'll go and define these 3. Let's go for delete operation. Now, delete operation is going to return us one value. So return type is integer. Q delete is the function name. It will have one parameter, Q variable. And from where we delete a value? We delete a value from front place. So let us have that value from our data array, but when we use data, it is a member of your Q, and it is array. So from array, which place? From your front place. So data of F will take that value, and we will return that value to user. But before we return, if we delete that value, then don't forget to increase your front. So Q points to F plus plus. That's what we need to do. So we take a value from front, we increase the front, and we return a value. But what if your Q is already empty? So if your Q is empty, you will not be in a position to take the front value. So if your Q is empty, front is -1 or front is greater than R, then we say Q underflow. We give a Q underflow message. And if Q is not empty, then in the else part, we take a value, we increase our front, and we return that value. Now, what is this VAL? So it's a simple local variable, and we initialize it to null at first place. So very much simple one. This is the delete operation on a simple Q. If your Q is empty, underflow message. Otherwise, you take a front value, you increase your front, and you return that value. If your queue is empty, then you are going to return null value. Otherwise, you are going to return the front value. That's delete operation. Now, there is very minor change in delete and pick operation. So I simply copy and paste entire delete operation, and I'm going to call it pick. And the change here is delete operation will delete that value, so it increases the front. But pick operation will only return front value. It will not delete the front value. So we need not to increase this front here. Remove it. That's it. That's the only change. Delete will update your front. Pick will not update your front. So that's pick operation. Pick operation will give you the front value. So if you just want to test or check what is the front value, you can call pick function. So that's the pick operation. And then the last one now, change operation. So it is not going to return anything void. QChange is the function name, and it will have 3 parameters. So make sure that what is the sequence of parameters. First one is Q variable, second one is position, and third one is value. Okay, so we use the same sequence here. First one is Q variable, second one is position, and third one is the new value we want to update. So here in this update place, whatever data value we have, so if we access data, Q points to data at a particular index, we are going to update it with the given value VAL. And this is how we can update the value. But how can we have this index? That's the first question. User has given us a value, position, and from that position, we need to calculate index. So from a position, we need to convert that position to index. Then it will be something like position will always start from front. Calculating your positions will start from front. So front plus you calculate it as a position 1, 2, 3, 4, and so on. So front plus the number of elements that you have counted for position. The front plus position. But as long as we are following zero base index, -1 at the end. So this is how you can calculate your index. And once you have your index, you can update the value at that particular index. But we cannot be so sure that user has given us a perfect position always. So before we go for this statement, we need to validate this index IDX. So we need to check the validity of IDX. If it is valid, then we update the value and we can give the acknowledgement message here. Value changed. Otherwise, we need to give a message like invalid position. Right? So we need to have one validation condition. Now, how do we validate that index? So that index must be within a range of your front and rear. Okay. Your IDX must be within the range of your front and rear. It should be in between your front and rear. Now we cannot write a condition like this way in a program. So what we'll do is we will separate these conditions and we will join those conditions with an operation here. Q points to front must be less than or equals to IDX, and at the same time your IDX must be less than or equals to Q points to rear. So that's our valid range of IDX. Now if this is the thing, then it's a valid index and we update our we update our data. Otherwise we say invalid position. Now you can keep only this thing in your change operation, or else in extra thing, if you want to have this emptiness condition to be checked first, then you can check it and you can have this entire thing within your else part. Okay, so if your queue is empty, you say queue is empty, there is nothing to update. Right, there is nothing to update. Or else you go validate your index and then you update your value. So that's the change operation, right? So now I can say that I'm done with my entire implementation of queue. Here we have defined our queue as an abstract data type, user defined data type, this one, and then we make use of that data type everywhere. We have gone for init operation, insert, delete, pick, change, display, empty, and full. These are the number of operations supported by this queue. Now let's go to demo file and uncomment these lines to test those functions now. As long as I have defined those functions, I can use those functions at appropriate places now. Okay, so now I call those functions from particular case depending on the choice, and I'm going to test it now. So randomly we are going to test any of the functions here. So queue initialized, we have that message and we have this one. So if I directly display, it should tell me queue is empty. Okay, so is it really empty? I can check it by option number 6, is empty function. So it says yes, queue is empty. Now if it is empty, definitely it is not full. So option number 7 should tell me no, it is not full. So we have those functions properly working here. Then let's insert few values. So option 1, insert 5. Oh, it is actually 55. Let it be. Then option 1, 66. Option 1, 77. Option 1, 88. So I've inserted 4 values and let me display it now. So 55, 66, 77, 88. We have 4 values here. Now what is the front value? So if we just want to check it, we go for pick operation, option number 3. Oh, connection lost. Need to run my program one more time. So again, I'll run this code and test it. Quickly inserting few values. 5, 6, 7, 8, and display. So we have 5, 6, 7, 8 here. Now, if I just want to check what is the front value, I'll go for option 3, and it should tell me front value is 5. So yes, it says front value is 5. but still 5 is not deleted. Again, if I display, I'll have those values as it is, 5, 6, 7, 8. But now if I delete one value, option number 2, then it says deleted value is 5. And now if I display, then I won't have that 5. I'll only have 6, 7, 8. Now, if I want to change this 7, so it is 1 and 2, position 2, second position. If I want to make it 1, then let's go for change operation, option number 4. It'll ask us to enter a position. Position is 2, and then it asks us a new value. New value is 1, let's say. Then it says value changed. Now, if really value is changed, then let us display. Instead of 7, you'll have 1. So we have it. And we have 3 values, so valid positions are 3. Now, if I go for change operation and position value is 4, if I insert position value 4 and any value I give, then it should tell me invalid position, because there were only 3 values. So valid position values were 1, 2, and 3. So that's the all over testing of my code here. And now I can say I'm done with my simple queue program. Then I can exit this execution. Done with the testing part. Right? So this is what the simple queue is. We had gone for 1-by-1 operations. Now you can perform your practical. Step by step, you should evolve your entire program. You can copy and paste the demo code from stack, okay? And then make necessary changes here. But when you go for queue header file implementation, write your each and every function from the scratch. And to get help, you can have your algorithm with you. By looking at algorithm, you can write 1-by-1 these functions. So now you go for your implementation of simple queue, and wherever you feel or you have any complexity, any error or doubt, you can ask me. We all are here till 11:30, and wherever you have a problem, we'll solve that problem and we'll complete this program today. I believe you just need to write a header file code only, 5 functions. So you'll be in a position to complete it by today in a single lab. Okay, so go for it. And now I'm going to stop this recording. Everyone will be performing their practical now. Do it.